Hello to everyone. My name's Jeff Houston. I'm the Chief Scientist at APNIC, and once again, it's a pleasure to speak with you in these COVID blighted times. However, you know, the end is in sight. I fervently hope, I think, as do we all, and very soon now we will be doing this face to face. Over the last few years, I have become fascinated by the domain name system. I suppose I have to come to the conclusion that if there were two things that bound the internet together as a single network, it was the addressing structure and the name structure. Now, unfortunately, we blew up the addressing structure, kaboom. This whole V4 exhaustion and the rise of NATs, and I would actually say address ambiguity, completely broke apart the thesis that every single connected device had a unique IPv4 address, and you know that was the internet, because that's not true anymore. Just isn't. And so the only thing that makes the internet is actually a common name system. And so the DNS is not only a fascinating protocol and an amazing ecosystem in its own right, it's the only thing keeping the internet together. So some attention on this is probably very, very well worth it. And so today, what I'd like to do is not talk about the DNS, but talk about the pressures that are shaping its evolution and where it's likely to go. And a word of caution, this is not a happy talk, okay? There are happy talks, there are really depressing talks. I'm leaning over into the really depressing side, so, you know, don't say I didn't warn you. It's true. The DNS is everything. Everyone uses it for everything. Every transaction on the internet starts with a call on the DNS. And if I could cozy up to you, and there are many ways of doing that, unfortunately, and see all your DNS queries in real time, I know you. I know you really well. I know what you're doing. I know what you're about to do. I know your interests. I know everything about you and the applications and software you run. So the DNS is extraordinarily informative, but it's worse than that, because it's not just informative, it's incredibly chatty and incredibly vulnerable. The queries are open and unencrypted. The payloads aren't secured. The DNS, you know, stub resolver just believes the first answer, whatever it might be. Tampering can't be readily detected. And quite frankly, false answers are injected almost as an industry these days all over the planet. Lots of folk pick on the DNS and deliberately manipulate it. Why? Because as a user, you're a victim. Where did that answer come from? Well, I don't know. I got one. Good. But is it the right answer? I don't know. I'll just use it anyway and see what happens. Users can't tell. That entire DNS infrastructure is completely opaque to the end user. So this is not good. This is not good for something that we rely on almost every single aspect of our lives, but every single aspect of our infrastructure these days. Hacking destroys oil pipelines for a day or two these days. Hacking destroys a national health system in Ireland. This is important stuff. And the name infrastructure seems to be close to a festering dung heap. It's just ill-attended, and we don't seem to be doing much. So let's look at what we are trying to do and see where this leads us. And there are three topics I'd like to talk about: authenticity, the reliance we're placing on the DNS, and trying to plug some of those ghastly information leaks. So how do you trust the answer you get back from the DNS? Well, the theory we've employed for the last 30 years, which, you know, has never worked that well in any case, is just if you send your question to the right IP address, you'll get the right answer. Nonsense. That's just no good. Particularly with UDP, anyone can fake any source address you like. No matter where your query goes, someone can intercept it and answer as if they were the real thing. So the first idea that 80% of the world's users still rely on is this naive idea that the internet's a benign and wonderful place, and we can all trust everyone to do the right thing. Nonsense. The other way is to be incredibly careful and digitally sign everything and validate every answer you get. And we call that DNSSEC. And so if you really want to trust the DNS, you've got to sign the DNS entries and consumers have to validate. So we should all be using it, yes? Well, yes and no, because this is a map of where users validate in the world. And we're in North America. Now, the good news is it's not colored red. Yay. The bad news is it's colored orange. Where is everyone using DNSSEC validation? Greenland's good. Iceland is good. Mongolia is good. And Saudi Arabia just turned it on. And the Scandies. But everyone else, not so. What an odd map. And so let's look at this a little bit further and look at the numbers over a period of, the last 7 years. It's a slow burn approach. It's a bit like the tortured long path of V6 adoption. And, yay, V6 has overtaken us, but, DNSSEC's now around 22% of users. But that thing below, 10% of users go to a validating DNSSEC resolver and it says, you're being fooled. I'm going to give you back serve fail because this is going to be the wrong answer if I gave it to you. And your user's resolver goes, for 10% of users, wrong answer. I'm going to use someone who doesn't validate because I prefer an answer, good or bad. Sigh. So, a little over 35% of users perform validation. But of those, 10% of the world's users go, nah, don't believe it. Bad is bad. It's not really bad. You just don't know what you're talking about. So that's on the validation side. Who signs DNSSEC zones? Who actually produces this? Well, public data on DNSSEC signing rates is incredibly hard to come by. So various folk, registries, etc., who actually have this data know a little bit about their corner of the DNS universe, but the larger picture of everybody and everything out there in the DNS, there's no real data. So the answer is, how many folks sign with DNSSEC? Some. And that's about as much as we know. Why isn't it everyone? Well, DNSSEC is a very mixed blessing. Digital signatures are big. And the problem with the DNS is it works best when it's tiny. It's UDP. It likes to be below 512 octets. You can't really put meaningful big signatures into UDP in that size. You have to be extraordinarily clever and use some of the latest encryption algorithms, elliptical curve, and try and compact things down. As soon as you do anything else, you're fraught with the whole issue of DNS and large responses. And quite frankly, everyone would prefer to avoid that. The other thing is, as a client, validating an answer takes an eon or two. You've got to backtrace and question it's your parent, its parent, its parent, all the way back up to the root. People don't live that long. And so this combination of transport uncertainty and this incredible time lag on validation has the world has said, yeah, we'll let recursive resolvers handle that. But in that all-important link from your recursive resolver to you, you don't validate. None of you do. And so if the recursive resolver lies, you're toast. And so DNSSEC is mixed blessings. Now, frustratingly, we can do better. We know how to do better. There's a bunch of technologies here which will really improve things. Are we deploying them? No. We know what to do, but we don't know how, you don't understand how we can all get there to do it. So that trade-off, people are just waiting. I don't know what they're waiting for, but they're just waiting. And so authenticity is a mixed blessing. The problem is that we can't do this forever because we are so reliant on the DNS now. It used to be really, really simple. I have a name. Hi, DNS, what's the IP address? Here's an IP address. Now your application goes, that's a good IP address. I'm going to open a TCP session on port 21. Yay, let's negotiate a service. And so in some ways, all the services sitting in that name share this common host IP address. Fine for 1990, not fine for 2021. We want a whole lot more. The service name and the platform that hosts that service are now very, very different because of a whole bunch of reasons, including the toxicity of the DNS and DDoS attacks. if you've got a really important service to broadcast on the internet, you go and find someone with a massive amount of capacity who does that for a living, and they do a damn fine job. But that means the service name and the host name are now different. And somehow the DNS needs to be able to make that distinction. A collection of platforms are now used to deliver one service name. One service, many IP addresses. We want to outsource electronic mail to one service. We want to outsource the web to another. We want to different services want to be outsourced in different ways for the same service name. So in other words, the generic DNS service now translates to many different services. And more to the point, these days with distributed content distribution networks, if you're in Mongolia, and I'm not, I'm down in the snowy, wintry depths of Australia, the best service delivery point is going to be different. And so delivering the same answer to both users is kind of not doing anyone a favor. You want them to go to the right service point. But the issue is, if I go anywhere first and get redirected on the second visit, I've wasted time, and I'm really, really not that sure that I'm going to go to the right point. It's the second one that counts. That's not good enough. If you want it to be lightning fast, you have to go to the right service point immediately. There is no time. And so the redirection to the right service point has to be in the DNS. And so we've tried all kinds of bells and whistles in the DNS. It started with this canonical name form. And then we decided that it wasn't just the name, it was the entire subtree, the DNS name, the D name. And then we found that you couldn't actually name the apex of a zone and do that with a C name. So some folks just said, why not? Let's just do it anyway. It kind of works. And others said, no, we need a new record, an A name, which is a true alias. None of them were very satisfactory. The problem is that as soon as you get any technology that has, 30 different solutions, it really is a clear signal you don't know what you're doing. Cue V6 transition strategies. 30 different solutions, we don't know what we're doing. Put that aside and move back to this, sorry. So what did we try there? We tried the SRV record. And if you look at that SRV record, it's either a really useful Swiss Army knife with all kinds of bells and whistles, or it's kind of, a step too far and it's a chainsaw massacre. Because what you actually do in the DNS query is add what you're going to do. You put on the query the port that you're after, the service name, if you will, and the protocol you're going to use, and ask the DNS with that additional information of the service parameters, allowing the DNS to then craft the right answer to, oh, it's the web, oh, it's TLS, oh, I'm going to give you this answer. And then, of course, there was the incredible idea that although the DNS is largely anonymous, that once your query heads into the innards of the DNS, your identity is not there anymore, which some folk regarded as a great privacy protecting feature, and others regarded as a problem that needed a solution. And we come up with the client subnet extension, where across the query, all the way through the DNS, I add my subnet. Well, I hope it's my subnet. And folk who have looked at this from time to time find an awful lot of ambiguity where it's not just your subnet, it's your address that gets added. And it's kind of, yeah, great, needed that, thank you so much. Now, of course, we've gone into even more bells and whistles because, once you start whistling, you just can't stop. And the latest incarnation is the SVCB and the HTTPS SVC resource record. That's a mouthful. This is the kitchen sink mega response, where if you ask a question with all of these attributes about where I want to go, what protocol I want to use, what port, etc., the mega response gives you the application level protocols available, the V4 and V6 addresses. I can even do encrypted service name indicator, the SNI field, and do encrypted client hello there. I can get priorities on various answers, everything. Oh, and by the way, there's an alias form as well, so I can alias at the zone apex. So, the latest bell and whistle. But that's a problem. And it's a problem we need to be aware of acutely, because we're taking the DNS away from being a mapping alias into being, where am I about to go? What protocol am I about to use? What port am I going to use? Because now we're optimizing rendezvous in the DNS, which means if I could see your DNS answers, I know with almost absolute certainty your next packet. I know immediately what you're going to do. Not just where you've been, what you've done, who you are, etc., but what you're going to do, which means DNS privacy issues become super, super critical. Now, that brings us to the third topic. What are we doing about that? Well, one of the first responses was, stop making the DNS so damn chatty. Don't tell everybody in the entire DNS cloud the full name you're going to go to. Minimize the information leak. Great move, tended to work well. Why did it work well? Because oddly enough, recursive resolvers are easier to change than all those millions and millions and millions of DNS host libraries that are out there. So query name minimization, largely adopted. So now we're going, well, okay, let's look at the edge. Let's look at that assets network where people play and play so badly, right? Let's add TLS, same as the web. Let's actually put transport level security in that all-important connection between the end user and their recursive resolver. Channel protection, remote end authentication, I know whom I'm talking to now. Transport robustness, great. UDP, difficult. So great advantages, some disadvantages. But let's go further. Let's do all of that and add HTTP object semantics with DNS over HTTPS. And let's go even further, because we can. Let's use HTTPS 3 and let's use Quick. So now I've not only got channel protection in the payload, I've got channel protection of that transport protocol. Now, this is good, but we can do better, because now we can do oblivious DNS over HTTPS, oblivious DO, and now we're separating who I am from what I'm asking through a technique of, if you will, double wrapping, which was, as far as I can see, borrowed a little bit from Tor, where you basically encode what you're asking in one level of encryption and encode who you're asking it from in the first hop in a second level. No one knows both things at once, as long as people don't collude, of course. Yeah, okay. So we have answers. And coming soon, we're even going to go further. We're going to put the DNS between the recursive and the authoritative. And it's kind of, are we? Well, we've done it for stub to recursive. This must be easy. Well, no, it's not. It's not, because we are in love with a DNS that no one pays for, a DNS that's free. And once you start adding this incredible overhead, it actually costs in terms of load on services, load on protocol, load on clients. And at some point, what was affordable becomes expensive. And to some extent, it's not easy to understand if we can do efficient, cost-effective solutions in this space. We can do it. Will folk pay? Tough call. And so this is part of this issue of scaling up, because this TCP overhead and even the quick overhead, you can amortize through session reuse. I establish a session, I ask lots of queries, all of a sudden inside that channel, it looks a lot like UDP. Session reuse is great. The problem is that when you get from recursives to authoritatives, there's not as much of that session reuse. So scaling that infrastructure is tough. The economics of the DNS can't go there. And somehow you either got to pay for your DNS queries, that's going to go down like a lead balloon, or we're going to have to be a little bit more cunning. And unfortunately, as folk have tried and failed, you can't use advertising revenue in the DNS. You can't play with the answers. You can't change NX domain into use my favorite search engine. That's not part of the game. And when you try that, and we have, people not only frown at you, they start to shout at you and say naughty words. So the question is, of course, now that we're touching on the economics of deployment, the real question is, will all these near-term changes get deployed? And the answer is, well, we know what to do. And if money was no object, we can do that. We can certainly deploy TLS, HTTPS. We can use DNS HTTPS SVC records. We can push DNSSEC everywhere. And with TLS, using a TCP-like transport, we can push big answers around without the overhead. We can use DNSSEC chain extensions and make the whole thing really fast. So we can. Will we do it? Oh dear. Oh dear. we point to HTTPS and we go, well, if the browsers can force the entire web ecosystem to use HTTPS, what's your problem, Jeff? Why won't the DNS just do this? And the answer really is, when you're trying to move a large amount of infrastructure, it's incredibly challenging. I don't think we really recognized the true extent of that V4, V6 transition as a scaling problem. It might have started as a small internet, in the late 90s when we thought this was a really good idea. But this is a gigantic internet with many, many points of investment, with equipment that has 5, 10, depressingly 20 years of service lifetime out there. Making a change when you're talking about things like CPE equipment is not, oh yeah, we can do this next week. We can roll out some firmware changes. It'll be easy. It isn't, and it won't. Now, people will change things if there's money in it. People will change things when they can see their competitors, if you will, tapping a market, either making more money or producing a cheaper service. But the DNS isn't that kind of economy. There's no untapped financial return in DNS resolution. For everyone, your DNS resolver is a cost, not revenue. And so where's the commercial impetus to change all the CPEs, to roll out this extraordinary amount of change to all move to TLS and DOE? Well, the answer is none. And more to the point too, there's an entire industry used by governments and many, many others in taking advantage of the openness of the DNS and using that oversight and alteration as a means of content moderation. The Great Firewall of China is, to a very large extent, DNS-based. And there's little appetite from all of these players to make that role harder to perform. And so not only is it difficult to do, but there are folk trying to stop you doing it. Now, if the browsers can push HTTPS, well, why don't the browsers just push this? Well, so far, browser vendors have had a much more limited amount of leverage in the DNS. They don't run the CPE, they don't run the infrastructure, they don't run any of this stuff. So how can they influence everyone else? And the answer is, well, not looking good. Because, like I said, you don't pay. And if you don't pay, it's a cost, not revenue. And all those efforts to monetize the DNS, to change the answer because you pay me, to change your next domain because I can basically say, that's not the name you're looking for. Try Jeff's Wizzo search service instead of giving you back NX domain. This is generally regarded as a bad thing. And when I say extreme disfavor, we tend to get into acts of, well, have we just done wire fraud by changing the DNS? You can't do that in the DNS and get away with it. And so open resolver efforts are by and large, with a couple of exceptions, success disasters. The more they're used, the more it costs the person running it. And so the more it costs, greater the funding problem. And so aggressively marketing an open DNS resolver says, wow, I really like burning money up in my front yard, don't I? Unless there's another business reason of cross-subsidization or some other form, and certainly with some of the open resolvers, you can see that particular motivation. For everyone else, it's just not there. So the DNS economy resists change. So it's little wonder that no one changes the default. Your ISP does it for you as part of the access service, you use it. 70% of all end clients, as when we measure it, use the same network resolve, the same network resolvers supplied by the ISP. Only 30% go elsewhere. But the issue is even those 30% actually are directed to other places by their ISP. Very few folk actually pay with the buttons on their devices. Very, very few. And if you're sitting there in NANOG going, but I do, what's the problem? The answer is, you're special. You really are very, very special. The rest of us don't do that. And so for that reason, the DNS doesn't like changing. And so we look at all these great changes to improve the DNS, to make it more resilient, to make it more robust, to make it harder to tap and change. You kind of go, well, is that going to become mainstream? Nah. DNS is going to stay in UDP. It's going to stay the clunky system that it is, because no one's going to change their settings to something better. And what we have now is affordable. And kind of that's where we're stuck. The Department of Good Ideas just can't sell this into existing infrastructure because it's going to cost and no one's going to pay. And so in some ways, we're kind of stuck here, or not. Because emerging from all of this is actually a different story. And the issue is that there are various applications, and don't forget, the money is in content, it's not in carriage anymore. And the folk who have money in content are sick and tired of a DNS that doesn't work well, are sick and tired of a DNS that's slow, are sick and tired of a DNS where you have to compromise authenticity and security because the rest of the DNS world isn't moving at their speed. And I said, they have all the money. And DOE is almost a unique opportunity to go elsewhere, to lift yourself out of the network and out of the platform, and don't rely on the user, you're the app. For the app to drive its queries about name resolution into its own infrastructure, an application selected name resolution service, I call it DNS, but I'm not sure if it will be in the long run, that basically bypasses all of those DNS over UDP libraries in the platform and bypasses all the config settings coming in from your ISP. The application ecosystem is going to move at a different pace. They are the point making the demands. And in some ways, if they can't force everyone else to invest in the infrastructure they need, if they really want it, they'll build it themselves. And they will make their own infrastructure and simply avoid waiting. Sucks to be you, but I've solved my problem. And we're seeing that attitude again and again in this application space. If I can't shift that gigantic anchor of deployed infrastructure and get them to spend money to make it better, I'm going to bypass it. I'm going to bypass not just that resolution infrastructure, I'm going to bypass that name infrastructure. And so the prospect of these application-specific naming services is not just an abstract thing, oh, it might happen, it might not. It's happening. It's part of now where these folk need to go in order to make their applications solid. And so what we're seeing is actually an age-old kind of answer, that folk who have the motivation and the money will stop waiting for everyone else to get the picture. At some point, they're just going to move and take their part of the game with them and do what they feel they need to do. And so the evolution of the DNS is actually, in some ways, its imminent destruction as a single cohesive name structure. We're ripping it apart because we simply can't move it all together along the same wavefront. And the folk with the urgent needs and money go and create their own solution. So, you know, with apologies to the Trekkies out there, you know, it's life, Jim, but not as we know it. Because this evolution from network carriage to platform, it was used to be Windows, didn't it, to application-centric worlds, is actually happening across the entire internet. And the DNS is being swept up in this shift. You know, the DNS is changing in every single respect. And the result is, if it's the namespace that's keeping the internet together, I have some pretty bad news for you. I told you it was a depressing talk. Thank you very much. I'll come back online at this point and we'll be happy to answer any questions you might have. Thanks indeed.
Hi, hello. Thank you, Jeff, for your presentation. And as expected, we have a pretty deep queue of questions. So let's see what we can get through here. Look what you've done.
Sorry.
All right. Okay. So started. Okay. From Patrick, I see two DNS providers in quotes. The huge ones, Google, Akamai, OpenDNS, Amazon, Microsoft, etc., and the little ones. Will the additional cost of TLS on the big ones be offset by not having to deal with the content reflection and other attacks? And I think the little ones do not care.
Patrick's talking about a slightly different area than I was actually referring to. I was referring to resolving. Patrick's talking about publishing. And there's no doubt too that centralization in the DNS, you know, who actually is your authoritative server is now a highly concentrated market in and of itself. their interests actually have a commercial aspect because you pay to have your name hosted. So yeah, they're going to do Doe and everything else under the sun because if Amazon does it, Akamai has to do it, etc., etc. Resolution, however, is a toxic economic wasteland as well as a toxic DDoS wasteland. And so we're seeing this sort of splits in the DNS where some parts actually have money, but the bits that matter to you and I, resolution, nah, nothing's changing. No one's paying. And that's the bit that actually is the bit that gets stuck everywhere. So yes, the servers will change, the clients won't. Oops.
Okay. Next question from Matt Petak. Why not do it like IPv6? Simply have governments mandate a change over to more secure DNS communication. And I hear you laughing already.
Great question. Do I need to say more? Aren't we in year 20 of this transition? We lived through exhaustion. We lived through something that was never meant to happen. And, you know, it's still not here. No, sorry, no. No. Next question.
Right. Okay. This was from Brian Holloway. Has anyone ever done an actual study on how much the migration of DNS to TCP, HTTPS, TLS, QUIT, etc., affects the bottom line of an eyeball network?
Well, you know, the problem is in so many ways that we put out CPE that has little bits of stub, shocking DNS. DNS mask is, you know, primitive stuff. And so the real cost isn't in changing my recursive resolver that I have deep in my infrastructure. It's changing the stuff deployed out there. And anyone in the ISP business, you know, sighs and weeps and moans over CPE. A huge amount of capital is out there, whether the customer bought it or whether I bought it. Running that, maintaining it, is a headache. And that's the bit that's so difficult to change. And, you know, V6 was basically sacrificed to the gods of CPE. It was just so difficult to get them to go dual stack, and it took forever. To try and change the DNS in that CPE, we're not going to live long enough. And it's sort of, there's no money out there. No one pays $100 a month to rent a CPE. No one even pays $1 a month. You know, nobody pays. And that's the problem here, that the big bit that gets difficult to change is the most numerous part of this. All those tiny recursive resolvers out there in user land. And so that's the problem. That's the bit that actually is making everyone else go, nah, not a problem I'm willing to solve. UDP is fine. I don't have a problem.
Okay. One last question, looks like, from Michael Doherty. DOH is a great thing, but what about our secure environments that need insight into what is being sent? Evil Bob has been sending DNS to a botnet and other not niceness for a long time using encryption.
There's a whole industry that relies on open text DNS queries over UDP. And whether it's clean feed in some countries or DNS block lists in my country and a whole bunch of others, enterprise VPNs and so on and so forth, yes, we have grown used to business models that rely on this visibility. And yes, Doe, and indeed a whole lot of actions around this area of increasing the armor plating in the DNS go directly against that. And this is pitting applications against infrastructure. Now, infrastructure would normally win because that's where the money is. Oops, there's no money left. The money is up in content. The money is up in applications. That money is talking. And what that money is effectively saying is, I'm going to make queries that protect the user of this application. And that's the bit that the enterprise folk have now got to grapple with. And there are no easy solutions out there. There really aren't. This fracturing and tension is going to resolve itself in splitting up the namespace. And, you know, the real thing you got to worry about is not whether enterprises survive this or not. I think it's irrelevant in some ways. Sorry. The real thing is actually wondering, once we break apart the namespace and the name that you try and resolve goes somewhere else to the same name that I'm trying to resolve, you know, what's the internet? What have we got left? There's no uniform address space. And if there's no uniform namespace, it's kind of, wow, whoops, I guess we broke it. So yeah, these are deep questions, and I wish I had really good answers, but these just are really, really deep questions. And what we're doing to ourselves by empowering that sort of area where applications are now asserting themselves in a way that's independent of the platform, independent of the comms infrastructure, independently, is actually creating a system that's very, very heavily fragmenting. So, yeah, that's the internet. Great.
Great. I think that was our last question, as we are out of time, unfortunately. But chat window should be open for a little bit longer if you want to engage there. So before we close the day, well, first off, thank you again for your time and presentation, Jeff.
Thank you.
Always a pleasure to have you here at NANOG, and hopefully we will have you in person soon.